Before we get into some examples, I wanted to talk a little bit about domain and range and also the ideas of even and odd. So I just wanted to remind you that the domain is everything that goes into a function. Every legitimate number you can plug into a function, and range is every number that comes out of a function. So keep in mind that our functions are defined this way, so that sine is just the y-coordinate on the unit circle, cosine is the x-coordinate on the unit circle, and the only things that prevent you from plugging numbers in is when you have like divisions or square roots of negative numbers, and neither of these functions have any of that. So the domain of sine and the domain of cosine are all real numbers. Tangent, cotangent, these on the other hand have some divisions. So anytime the x-coordinate on the unit circle is 0, tangent will be undefined at those points. So that would be like the top of the circle, and the bottom of the circle have x-coordinates of 0. So at 90 degrees, at 270 degrees, tangent's undefined. And cotangent undefined anywhere the y-coordinate is 0. So I'll let you read about that in the book a little bit more. I just wanted to give you a little bit of an introduction to that. And range, I guess we should talk about range too. For sine and cosine, the range, the outputs are just the x and y coordinates. So the biggest the y ever gets is 1. The smallest it ever gets is -1. So that's your range for sine. Same thing with cosine. The biggest it ever gets, x-coordinate is 1. Smallest -1. These others, since they're divisions, their ranges can get bigger. And again, I'll let you look in the book for the rest of the details on that. It's easier with their professionally drawn graphs. So I also wanted to talk a little bit about even and odd. I just wanted to remind you there that the idea for an even function is that when you plug in some value, you get the same result as if you'd plugged in the negative value. So maybe plugging in 30 degrees gives you the same thing as plugging in -30 degrees. There's some trig functions that work that way. And odd says if you plug in like -30 degrees, that's the same thing as plugging in +30 degrees, except opposite sign. And there's some trig functions that work that way also. For the even ones, where if you plug in 30 and -30, you get the same result. Notice that like going to 30 degrees would give you square root of 3 over 2 for an x-coordinate, and going to -30 degrees would give you square root of 3 over 2. So the x's are the same here. So any function that gives you the x values, like cosine, is going to be an even function, because that's the same for any points, no matter how far you go in either direction. The y-coordinates are not the same, by the way. They're the opposites of each other, which means that sine is not an even function, but giving the opposite, sine is an odd function. So there's a couple functions that are even, which are cosine and secant, and the other 4 are all odd functions. So sine, tangent, cosecant, and cotangent. And mostly we're just pointing that out right now. We're going to make use of that some in the homework, and we'll also make much more use of it when we start looking at the graphs of these things. Okay, but let's go on to look at a couple examples. First one I wanted to look at was, say if sine of some angle is 5/13, and let's see, and we're in quadrant 2. The question there is going to be to find out the value of all the other 5 trig functions. And notice that 5/13 is not one of those points we have memorized, or that we're working on memorizing, around the edge of the unit circle. So it's not that we're just going to be able to look at the unit circle and figure out where we're at. But If we could figure out cosine, then we'd really have sine and cosine, we'd have x, we'd have y, we'd be able to figure out everything else. And one other reminder from the intro is that sine squared plus cosine squared equals 1, and that just comes again from the fact that the unit circle is defined to be x squared plus y squared equals 1. So if we know so we've got that sine squared plus cosine squared equals 1. And if we know that sine is 5/13, we could say 5/13 squared plus cosine squared equals 1. And we can solve that for cosine and figure out the value of cosine. So 5/13 squared is 25 over 169. If we subtract that from both sides, you get cosine squared equals, let's see, I need to do that. It's 144 over 169. If you take the square root of both sides, keep in mind there's two square roots. There's the plus and there's the minus. It becomes 12/13. Oh, sorry, this is cosine of t. So cosine of t is either 12/13 or it's negative 12/13. Which one is it? Well, hey, we know back up here that we're in quadrant 2, and cosine in quadrant 2, keep in mind quadrant 2 is this portion right here. Cosine's the x coordinate, so in quadrant 2, cosine is negative. So we know that it's not the positive version, that cosine is negative 12/13. So we've got the value of sine and we've got the value of cosine. Which means now we can figure out the other 4. We've got 2 of them already. But the other 4 just come from the fact that tangent is y over x, is sine over cosine, cotangent's x over y, so we can get the other 4 based on that. So I'll just, well, maybe we'll do all of them. Let's see how far we get. I'll say tangent of this angle is the y over the x. So it's 5/13 over negative 12/13. Flip and multiply. You get 5/13 times negative 13/12. Cancel. So tangent is equal to negative 5/12. Cotangent, I could repeat that process, but cotangent is just a flip of tangent, so I already know that cotangent is negative 12/5. And secant is 1 over cosine. All right, so it's the flip of cosine, so I already know cosine is negative 12/13, so secant is negative 13/12. And likewise, cosecant is the flip of sine. Sorry, cut off the bottom of the screen. So 5/13 goes to 13/5. Okay, so that's just a couple examples from the homework.